Good morning. Today I want to go through how to solve kinematics equations. Kinematics is the study of motion. There are lots of variables. This can be a more difficult concept. So first, the content and language objectives. The content objective is I can solve kinematics equations. The language objective, I can write my step-by-step process to solve kinematics equations. And so what I'm going to help you do is go through the process of writing down equations you might need, adding to your formula sheet, again, writing down the step-by-step process for solving problems. And then for today, there are just two problems I'd like you to try to complete. Again, because these are challenging and we can go over them next time. First, go ahead and click on this assignment to open your kinematics equations worksheet. And that worksheet, I just want to go over the basics before we get to the problems. First of all, to review, there are 5 different variables that are important here that we're going to go through. The first is displacement. Displacement is a change in position. So how far you end up from where you started. Velocity is measured in meters per second. It's speed with direction. It's a vector. Acceleration is the rate of change in velocity measured in meters per second squared or meters per second per second. Time measured in seconds. And so again, we have 4 different variables. But we're also going to worry about velocity at the beginning of a scenario, v sub I, velocity initial, and v sub f, velocity final, or the speed with direction at the end of a scenario. For kinematics equations, there are 5 different equations that you're going to use. And the reason there are 5 different equations is because there are 5 different variables, and each of these equations has 4 different variables in them. And so my step-by-step process for solving problems, it might be different than yours, but it's going to be number 1, to figure out in a problem what information you're given. And so in example 1 that's provided below, I just look for numbers to start. And so you're always going to be given in problems 3 different pieces of information. And again, with number 1, you need to figure out what is 12 meters, what is 5 meters per second, what is 4 seconds, which of the variables, acceleration, delta x, velocity final, velocity initial, time are those. And so I like to pay attention to units. 12 meters, that is a measure of distance. And so that is your delta x value. 5 meters per second, it says the initial velocity was 5 meters per second. If it's not giving you verbiage like this, what you want to pay attention to is this at the beginning or end of this scenario. And then 4 seconds is a time. And so that's step number 1, figure out what you're given. Step number 2, you need to figure out what you're solving for. And here at the end of the problem, it says, what is the acceleration? So you're solving for acceleration. Looking at the variables listed above, we know your distance or delta x. We know your 5 meters per second is your initial velocity. We know that you're solving for acceleration, and we know that your time is 4 seconds. The reason that's important is the second, third step is to figure out what variable is not used. And in this case, it's velocity final. It's going to tell you which equation you will use to solve this particular problem. And then what you'll do is you will use PEMDAS. You will plug in the values that you know, worrying about things in parentheses first, and then exponents, and then multiplying, and then dividing, and then adding, and then subtracting. Do them in that order so that you come up with the correct answer. So what I wanted to do is just go through one problem, start to finish, to see how that works. And then if you have any questions, you're always welcome to hop on and ask them. But the example that's given here, number 11 is what I want to go through. It says a car stops in 120 meters. If it has an acceleration of negative 5 meters per second squared, how long did it take to stop? And so step number 1 is underline any values that are given to you. You'll notice that we only have 2. And so a car stops in 120 meters. 120 meters is the unit we're looking at here. And so I'm not going to put anything other than 120 in here. I know the units are meters. We'll worry about that later. It says it has an acceleration of, and again, if you look at units, meters per second squared or meters per second, this is your acceleration. And then we need a third piece of information if we're going to solve. It says that a car stops in 120 meters. Sometimes it won't exactly tell you something, but if something comes to a stop, what that means is your velocity at the end, your speed, is 0. And so we know step number 1, uh, what we're given. Step number 2, you need to figure out what you're solving for. It says how long, and we're not talking long distance, we're talking time. Does it take to come to a complete stop? And so that's what we're solving for, which means velocity initial in this scenario is not used, which means we are going to need to use this equation where velocity initial is not used. Uh, Again, you just type that out, write that out. Delta x is equal to velocity final times time. So I'm just going to write it out here. Delta x is equal to velocity final times time. And then scroll back up, get the rest of that equation, plus 1/2 at squared plus 1/2 at squared. And so that is the equation that we're going to use. What you need to make sure is we're doing things the way we're supposed to. So I'm going to put parentheses around things so we take care of the things in parentheses first, like we're supposed to. And so we've done step number 1. We figured out what we're given. Step number 2, what we're solving for. Step number 3, what are we not using? So what equation are we going to use? And now you just need to plug in your values and try to solve. And so delta x is 120, is equal to velocity final is 0 times time. So it doesn't matter what time is. We've got 0 here. Plus 1/2 at squared. 1/2 times -5 times t squared. And so 120, to simplify, is equal to -2.5 t squared. And then we would divide each side by -2.5. Plug in your calculator and solve. So, ladies and gentlemen, that is the step-by-step process of how to go through a kinematics problem, to figure out what variables you're given, to figure out what you're solving for, to determine which equation you're going to use, and then solve. Thank you very much. If you have any questions, please stop by office hours. I'd love to help you out. Have a great day.